Let's revisit that question and add some more parts to it. Now that we've watched the previous example, how we actually went about solving it. The time it takes to construct a widget is normally distributed with a mean of 10 minutes and a standard deviation of 2 minutes. So let's start again. What does A tell us to do? Find the probability it takes an individual less than 12 minutes. So this is the time it takes. It's normally distributed. The mean is 10. Standard deviation is 2. Probability that it takes less than 12 minutes is going to be the area in here. We already established that Excel has a function that gives us exactly what we want. We can just go from here. We can say it's going to be norm.dist. So norm.dist works for any normal distribution. Does not have to be standard normal. We don't have to standardize it either. I'm just going to put an X in there. So X is the amount of time it takes to put the widget together. Specifically, we want to know the probability that it takes fewer than 12 minutes. 12, then we want the mean, which is 10, standard deviation, which is 2, and 1. So it's 12, 10, 2, and 1. We've already done that. Let's have a look. We did that in the earlier video. So there you see, norm.dist, 12, 10, 2, and 1, and it gives us the answer. It's equal to 84.13%. Incidentally, this question asks what's the probability that it takes an individual less than 12 minutes, and we come with 84.13%. If the question said less than or equal to 12, so it actually included the 12 as well, it would make no difference to the answer because this is a continuous distribution. So less than 12 minutes, what could you say it is? What's less than 12? You could say 11, but that would be for a discrete distribution. But we have values between 11 and 12. We've got lots of values. We've got an infinite amount of values in here. So less than or equal to 12 would be the same answer. Less than 12 will still be the same answer because less than 12, as we're doing right now, you may say, well, it's going to be 11.99 because that's less than 12. But you say, but 11.999 is less than 12 as well. So how about 11.999 at infinitum? So 11.99999 going on to infinity is basically 12. So there's no difference with continuous distributions. If it says less than or equal, it would be the same response. So let's look at B. What does B ask us to do? Find the probability that it takes an individual more than 12 minutes. So X, same thing, supposed to be the same thing there, not exactly that, there you go. More than 12 minutes is going to be this over here. Okay, do we need to do any big time work on that? Probably not, because we should realize that the area under the curve is 100%. So we already established that the area over here is what we want. We already established that this area, do it in green, this area, we already established that this area is 84.13. So the area that we now want, this red area, is the same red area down here. Well, what should it be? The area under the whole curve is 1 or 100%. So the red area that we want is going to be 1 minus 0.8413, which is going to be 0.1587, which is 15.87%. Okay, so even though XL basically works to the left, it only gives us values to the left and less than, and we wanted a value which was greater than. Well, greater than is just going to be 1 minus less than. The sum of these two parts must come to 100%. We've established that the green part up here is 84.13. Now that means the red part that's left over must be 15.87 to give us 100%. So that just means 1 minus the green gives me the red. They must add up to 100%. So it's as simple as that. And let's look at part C. Find the probability that it takes an individual between 9 and 12 minutes. Okay. 9 and 12 minutes. So again, try and do the same thing in here. The random variable, what we're looking at, the amount of time it takes to put a widget together is x. Normally distributed, mean is 10, standard deviation is 2. They want us to be between 9 and 12 minutes. How are we going to do that? 9 is here, 12 is here. So we need to find the area in here. XL only works to the left. How are we going to incorporate that? Well, what we can do is this. We can say, look, we already know for this distribution, mean is 10, standard deviation is 2. I can actually work out this area in here all the way back to 0, all the way back to, sorry, negative infinity. I can actually work that area out, and we've done it above. It's going to be 84.13. But that area is too much. That is, we wanted that area to stop off at here, at 9. We didn't want all this. So 84.13 is everything. So we didn't actually want this in here though. So if we could subtract from the 84.13, if we could subtract that red area, then we'd be done. So what is that red area? Well, XL does work to the left, so we can use norm.dist. Nine, 10, 2, and true. Let's go over there and work it out on Excel. So norm.dist, a little bit more quickly. So norm.dist, 9. So 9, mean, standard deviation, and true, gives me 30%. So it's the difference between these two. So if I say it's the 84.13 minus the 30.85 gives me the answer. And our answer is 53.28%. So let's go over to here. So the red area is going to be 30.85%. So we're going to subtract from 84.13, so it'll be 84.13, which is the total area in black, subtract the area in red, which is 30.85, and that's going to give you an answer, just a different color, that's going to give us an answer of 53.28%. 53.28, and that area is in fact this area in here. So a little recap. Less than a particular value, you just use norm.dist, gives you less than. Greater than, it's 1 minus norm.dist, and between 2 points, you're going to do norm.dist of the bigger point, and you're going to subtract norm.dist of the smaller point. Before we do D, Could we have solved this question up here, any of these, or this one here, in an easier way? Could we have used the empirical rule maybe? Let's look at this one. Could we have used the empirical rule? We could have done, because for this particular question, we were exactly one standard deviation away. So if we go plus or minus one standard deviation, the empirical rule tells us that we're going to get 68% of the observations in that range. 68% of the observations, which leaves us 32% to get up to 100, which is 16% on this side and 16% on this side. So according to the empirical rule, the answer to this would be 16%. We got 15.87. So the empirical rule is an estimate. It's a rough estimate. So we could have used the empirical rule on some of these. Finally, D. Find the probability that it takes an individual exactly 7 minutes to construct a widget. Do we remember how to do that? So cool. Pretend that we've forgotten how to do it. Exactly 7 minutes might be here. The answer is 0. Remember, for continuous distributions, the probability of getting an exact response is 0. So the answer here is going to be equal to 0%. For continuous distributions, you actually need an area. On all the ones above, we actually had an area that we were actually trying to calculate. At a single point, the probability is equal to 0.